Hi guys, it's Miss Adams, and we're going to be looking at today's first page of notes with AMDM, and we're looking at the estimating crowd notes. So some of you may be wondering, why are we looking at estimating crowds? What would be the purpose of this? So estimating the number of people in a large crowd, so like if you're at a parade, if you're attending or marching in a political rally, or if you're like attending a concert, sometimes it can be quite challenging and often leads to controversies. Whether people like more room, whether they like less room, they want to sit, they want to stand. These are some of the controversies we may face. So one method that we sometimes use to focus on a small section of a crowd, such as a rectangular area. So instead of looking at the whole crowd, let's just look at one section and estimate the amount of people that could be for the total section. So in class today, we did something where we had a 5x5 square on the ground. And we said, all right, guys, let's see how many people we can fit in this 5x5 square. So we had a square that looked like this. That was 5 feet by 5 feet. And we need to find the area of this square. Well, 5 times 5, because I know that area equals length times width, is 25 feet squared. So we had all these people go in, they tried different ways to go into the square, and they were really packed. And we roughly got 17 people into the square. All right? Now, in today's notes, we're going to be using this golden ratio, and we're going to keep using it because we want to, or we're going to keep using it throughout the notes. So we're going to be comparing people versus, let's see here, let me get to black, there we go. People versus their area. So we want to see the amount of people, we're comparing the amount of people per a certain area of space. Well, in this case, we had 17 students, or 17 people, in a 25-foot square area. Now, we're going to use this idea of cramming 17 people into a 25-foot square area to estimate the size of a crowd that is 10 feet deep on both sides of the street, standing along a 1-mile section of a parade route. So I'm just going to draw something to kind of give you an idea. So we've got two sides of the street here. We've got our street in the middle. And we've got people standing on either side. And they're standing in 10 feet deep. And it told us this spans 1 mile. Well, going back to our conversions, I know that 1 mile equals 5,280 feet. So I know that the length here is 5,280 feet. But now I need to find the area of this space on the sidewalk. Well, length times width is going to give me an area of 52,800 feet. But that's only for one side. So I know that the area of one side is 52,800 feet squared. But I don't know how many people can fit on one side. But I can compare it to what we did above. I know I had 17 people cram into a space of 25 feet squared. I'm now going to compare this to some unknown amount of people. So I'm trying to find the amount of people because I'm estimating the size of the crowd. And I'm only going to look at one side first. So we're looking at one side of the street. So that's 52,800 feet squared as my area. Since I'm doing this comparison, I can now cross multiply to solve for x. So I'm going to multiply right across. You guys might remember this as the butterfly method. Now, I'm going to be honest with you guys. I don't draw great ovals, never have, never will. So bear with me there. I've got 25x is equal to 17 times 5,000 or 52,800. And that's going to give me 897,600. And remember, this is just for one side right now. So now I'm trying to find the people that can fit on one side I'm going to divide both sides by 25 to isolate my x value. So on one side, there are 35,904 people. I can now multiply this value by 2, because there's two sides, to get attending this parade. If I squeeze everybody in like we did in the square, so multiplying that by 2, we can get approximately 71,808 people on that street for the parade. But guys, that's really cramped. So let's keep on moving through here. And it says, one rule of thumb for estimating crowds is that each person occupies 2.5 square feet. Whew, okay, this is better for us. So now there's some moving room. We're able to do a few more things. So I know that one person now, so this is my new ratio it gives me. So each person, so one person is going to occupy an area of 2.5 square feet. Now, utilizing this, I want to figure out how many people can fit comfortably at the parade. So, once again, I don't know the number of people, so I'm going to call that X. You can call it any variable you want. So I'm going to say X amount of people. And guys, I'm going to find for one side first, then multiply by 2 to get to both sides. So I'm going to use that area of 52,800 feet squared. And we're going to cross multiply. Well, I've got 2.5x equals 1 times 52,800, which is just itself. And to find the amount of people on one side, I can divide both sides of this function by 2.5. That's going to give me that x, so, excuse me here, the amount of people per one side is 21,120 people per side of the road. But I want to look at both sides of the road, so I'm going to multiply this by 2. So total at the parade, comfortably, we could fit 42,240 people. So guys, let's reflect on this just for a second. When we talk about those controversies, we're talking about how people could fit comfortably, whether they're standing, whether they're sitting, whether they have room to move around, whether they're on each other's shoulders. So other methods that can be used to estimate the size of a large crowd, well, you could see how many tickets were sold, and by the amount of tickets sold, you can pretty much guess how many people are going to be there. You could look at stadium seating. Well, if the stadium is full and you know the amount of seats, then you can pretty much guess how many people are there. But the stadium's only half full, then divide it by 2. There are a few different methods to do this. So when we continue on with these notes, we're going to look at a couple of these different methods and analyze just different ways we can continue to see how we can estimate crowds and how we can look at capacity.